So ground wave propagation. So who will transfer this? The surface of the earth will act like this. So here, as we know, the surface of the earth is a curvature, no? It is not like something straight line. So we'll show the curvature. So the transmitting station, I'll just show like this, like just some tower, everything. So there's a practice. So you just write TX. What do you mean by that? It's a transmitting station. These are symbols what we use here. It will generate. Now, what is the thing that one? The wave which is generated, I'll see that the electric field vector will be directed normal to the surface of the earth. So what is this? What we have, this is. Okay, no. So this is something like a surface of the earth. So now the transmitting station will see that the electric field vector will be the EM wave will be generated such that the E bar will be perpendicular to this one. And how B bar will be directed perpendicular tangential to the surface. Now the wave will propagate in what direction? Along the surface of the earth. So as it propagates, then as it propagates, its E bar vector magnitude keeps on decreases. And let my receiving antenna be here. Receiving station. We use RX, receiving station, that one. So this E bar vector will be directed. So as it propagates, we know the electric field vector, and this will be the atmosphere. So we know the E bar vector should be always directed from higher to lower potential. So here we'll get a induced charge. As the wave propagates, the induced charge will also propagate. Or shall we put like some current I is flowing. So this will be the direction of propagation, the wave. And B bar vector, I think it'll be a little bit difficult, or else I'll show B bar like a dot out of the plane or into anything it will be. The wave will propagate here. We know the E bar vector will be directed from higher to lower potential. So the surface of the earth will have a positive charge. No. When the wave is here, the induced charge will be here. No? When the wave is, the induced charge is here. When the wave is here, the induced charge will be here. So now as the wave propagates, the induced charge also will propagate. And sir, what about the negative? The negative will be given to the lowermost layer of the atmosphere. Here the negative charge will come. Okay, let's not bother that showing all that one. The lowermost layer will acquire that negative charge. And then, so we know that the induced charge propagates, the rate of flow of charge will constitute current. And this current, where it should flow? On the surface of the earth. And we know this earth is like a conductor. It's having some good conductivity. If not very high, at least some conductivity will be there because it is made up of some metals here, that composition will be there. So therefore, there'll be some conductivity will be there. And because of that, the current flows. And we know that whenever a current flows, it must be generated. From where that energy should come, the energy of the wave decreases. Are you looking at the amplitude? The amplitude decreases. If amplitude decreases, the intensity decreases. So as the wave propagates, the energy of the wave keeps on decreases. This is what happens here. So at the receiving station, if it's having certain amplitude, so then the receiving station will take this wave. Nothing but here antenna will be there. The antenna will capture these waves, will receive these waves, and given to amplifier will increase the amplitude. Then the signal will be processed further. So now, who is a medium now? The earth is a medium. So let's summarize all the points. So medium, who is a medium or channel? What is like a medium or channel? Who is that? Surface of earth. Surface of the earth is responsible for transmission of ground wave. Or I'll do one thing. This will be again. Surface of Earth is responsible transmission of wave. What is EM wave only? When I say wave, it's the EM wave. Or the surface of the earth guides the wave. Guides, okay, all of you, guides. The earth will see that the wave will move from one point to another point. That they use the word guide in some book. Surface of the earth is responsible for transmission of wave. Fine. And next again, the what will happen the wave? Why do the energy gets decreased here? So again, if you look at the wave what happen when it is moving from one point to another point. So what can be this distributing transmitting distance? It can be 40 kilometer, 50 kilometer, 1,000 kilometer also. I think when I think I was in school. So these are called like a microwave stations. No, we don't have. I think in Hyderabad, there are 7 microwave stations are there. Now they have closed it because we are not using, no longer we are using this one. But I think 1980s till 2000 we were using. After that, we stopped using it. The telephone, what all, everything, no, the communication was this one only. These are called like a microwave station, not microwave oven, micro station. So then what happened? That particular transmitting station will radiate the energy as it propagates. For almost, I think it is around 100 kilometer or 200, 800. It all depends on power of station. Another station will be there. What this station will do, will receive this energy and will further transmit. Like that, what happened? We used to have a global communication. People from America used to communicate. But sir, how come stations from America to Europe, it used to be some other mode of skywave propagation. From the Europe again to the different places of Earth, they used to communicate. Like that, the global communication also it was used to happen. Okay, maximum what happened, the India in India or most of the world, no, they were using this for the telephone. Earlier, the telephone was using this. Later on, what happened, fiber optic cable, satellite came, then we stopped using it. Got this one? So this can be distance some few hundred kilometers to few thousand kilometers the range. So what about the range? Few hundred kilometers to few thousand kilometers. This will be the range here. So next again, after this, what will happen this one? So as suppose say like a Hyderabad to Vijayawada, how much? Around 250 kilometers. So now the transmitting station is in Hyderabad, the receiving station is there in Vijayawada. Then as the wave propagates, I think in between we do come across many towns, villages, lakes, hill, river, agricultural fields. So how that particular different terrain. So shall I say terrain, the surface of the different types of surface of the earth, we call that as terrain. So as the wave encounters different terrains, then what be the behavior of the wave for that? So if you look at the concrete buildings, the concrete buildings, hills, rocky layers, all that one will offer high attenuation to ground wave propagation. So if a signal passes through any, suppose Hyderabad city, definitely what happens, the signal amplitude will decrease a lot because everything well concrete, no, the cities or towns what happen, we have a buildings, no, they'll offer high resistance for the propagation of wave. And because of that, what happens, the energy of the wave will decrease. So offer high attenuation. Okay, attenuation agreed, no, the word, the decrease in amplitude. So whereas what will happen, the lakes, ponds, forest, agricultural fields, green landscapes offer very less attenuation to ground wave propagation. So therefore, when I am transmitting the wave from the transmitter from Hyderabad to Vijayawada, so how the path I should pick up, it should be a straight line. No? Don't think that one, it will zigzag like this. No. So if this is the Vijayawada and this is Hyderabad, you can't do like this. Sir, here, uh, I think we have what? Any town name? Suryapet. Suryapet will be there. So can we do one thing? Can we send a wave like this? Then, yes, if you have again in between, if you have in between one more repeater, okay, you can do that one. But if you have only transmitting and receiving station from Hyderabad to this one, if I have Surapet, then no other problem. That's why what happened, you have to locate somewhere here. But again, the signal should be there. So if you have any towns, no other way. So you have to increase your strength of signal. So therefore, when they connect, when they're using ground wave propagation, they have to see that the less number of towns and the villages should come across that particular line joining the transmitting and receiving stations. Or else what they do is they go for repeater. The repeater they'll place somewhere here. First they'll send signal here, then they'll send here. This is called a repeater. What is the duty of it? It should gather signal from Hyderabad station and amplify it, and it should send back here. So some repeaters, they can place it. So this was the planning earlier they used to do. So what is a repeater? So I'm using word repeater. So what's the repeater does? It will collect the ground wave propagation wave, shall put ground wave, propagated wave, amplifies and retransmits. It will not do anything. It will not process it. It will just collect, increase the amplitude and retransmits it. Like this, there's a duty of repeaters. Like that, by using number of repeaters, we can increase the distance between transmitting and receiving station. There's one alternative. Okay, after this will come. What about the range? The range depends on power, frequency of signal, and diffraction effects. So first we'll go for the power, frequency, range, all those things, and then we'll get some better idea. And now if you have the power of a transmitted wave is say like a 100 watt. The frequency is 2 megahertz. Then the range will be 800 kilometers. I think it's not a small thing. You check it. If the same power of a wave is 100 watt and the frequency says some around 25 megahertz, then it will propagate up to only distance of 60 kilometers. Then if power of this is 10 watt, the frequency say like a 2 megahertz, then it will propagate up to say like around 70 kilometers. So therefore, what does it mean? High power will have more range. Are you able to compare? Power 100 watt, frequency 2 megahertz, 2 megahertz. Power 100 watt, frequency 2 megahertz, the range is 800. I mean the distance between transmitting and receiving station. Power is 10 watt, the same frequency 2 megahertz, the range will be 70. So therefore, shall I say the range depends on power? Okay, no, let's compare these two here. Power 100 watt, 100 watt, but the frequency is low, here it is high. Whatever the range decreases. So for as the frequency of the signal to be transmitted increases, the range decreases. Why we have to give reason why? Because of as you increase frequency, what will happen to wavelength decreases. And what is the surface of the earth? Contains most of the things like a stones, all the sand, all things of small objects here. So the wavelength of the wave, what will happen when it becomes comparable to the size of object what it encounters on the surface of the earth, then the diffraction effect will come. What is the diffraction? Bending of ray of light. So now due to diffraction effect, so what actually happens is like so the wave, it is in fact transmitted. Due to diffraction, the wave starts bending. Amplitude decreases due to attenuation. And finally it will sleep. I think the further propagation will not occur. It's over. So this bending of a ray of light will take place here. So shall I say that range depends on, so the range decreases So at this particular point, once E bar becomes parallel to surface of the earth, no more propagation, finish over. Because how do it reach? Because somewhere the receiver is here, no? Our receiver is somewhere here. Can it further propagate? How B bar will be like this? I think it cannot propagate along the receiver, no? Finish over. The wave will die out. So due to diffraction of development, the E bar vector will start bending. Why do this? I think property of diffraction, no? Bending of ray of light encounter sharp edges. Why do that sharp edges? Here, this one. What all we have? The surface of the will it be smooth? Nothing, it contains sand, rocks, everything, so many things, no, hard substance. And if the dimensions of that hard substance becomes equal to the wavelength of the wave, then diffraction phenomenon will be noticed. Yesterday's discussion, when the size of slate becomes comparable to that of the incident wave, we see diffraction. When the size of slate is more than that, no diffraction effect. The similar thing here. Okay, this about the thing different. So what? One more diagram. So it is like a. What about the wavefront? How the wavefront will be? There's sometimes possibility of testing wavefront also. They may ask you if the wave propagates. If the wave propagates, I think the wavefront will be because how the wave will propagate in this direction. E bar vector, I'm not showing it. E bar vector. E bar vector, you have to show that one. I'm talking in terms of wavefront here. So what is this? This will be wavefront. So who will guide the surface of the earth and the lowest layer of atmosphere will guide that particular wave. Okay, here in terms of E bar vector, I'm showing this will be in terms of wavefront here. Okay, fine. This is, I think, some just story, no, nothing big. You don't have to do any research here. Okay, this is about the ground wave propagation. Okay, next we'll go for line of sight propagation. Line of sight or space wave propagation. And next type of, we'll see that what benefits we'll get in this type of propagation. I'll have water. Okay, if you want, you can wave it. I'll have water. No, this collocated